Good evening, ladies and gentlemen. Today I'm starting out looking into how to import textures from Descent into Unreal. We've got almost have the level geometry, and now we need to import the textures. So I don't know exactly what's going on with the texture import in Unreal, but I'm not seeing where it's importing the textures. I've been doing a little bit of digging before the stream started to kind of get my bearings here. And we've got a file name, and then we open that file, we read the data start, and then no, that's, I missed this one. Use short, unsigned short, that's 32 bits. Game bitmap xlat. Don't know what that would be. Anyway, so we read all the bitmaps, except if you go to read all the bitmaps, it's not actually pulling in the bitmaps themselves. It is reading the textures. I believe this is a short. Yeah, it is short. It's reading the textures, the index of the bitmap, and then the header info of the bitmap. So we've got lighting, damage, the eclipse number, I don't know what that is, and the file name. No bitmap data. And I'm trying to figure out where our bitmap data is. And so the pig file then goes to pig data start, and then it reads in the number of bitmaps and the number of sounds, and then it reads, and then it gets the size of the next things it needs to read in. I'm not sure it uses this actually. Way down here in sounds. Okay. And then for each bitmap, it reads in a bitmap header, which is also exactly what it sounds like, a header. We have a name, we have flags, we have width, height, or so D flags, width, height, flags, average color, and offset. No bitmap. Then we do some stuff with that bitmap header, and interestingly enough, we assign bitmap data here, but this doesn't look like it. I can't figure out where this is built. Yeah, this is really weird stuff. And then we register bitmap. Yeah, we register the bitmap at the end, but there's no other reads here. So if we're looking at register bitmap, let's see here. We're inserting into all let's see here. We have game bitmaps, BMP. We have all bitmaps, game bitmap offset, and game bitmap flags. There's a lot of stuff working for this here. So game bitmaps is a GRS bitmap, and GRS bitmap has this pointer to BM data, right? That's supposed to be some specific size. I suppose I should look for uses of this pointer. Because that's the only time I can think of, like, and it's not pulling it. So if I look for bm underscore data, we have 3 references. The one I'm looking at, also the one I'm looking at, and in Piggy, but that's not working correctly. Do I have a space in front of it? I do. That's better. So I've been looking at bm.c. Looks like we also have a bitmap.c. Create bitmap, width, height. Oh, and it's worth noting that the Piggy file, oops, sorry, Piggy.c here. When it's initialized, it doesn't get closed. They do this atexit Piggy close file. And if we go to definition of that, that is a function to be called when exit is called. Register a function to be called when exit is called. That means that this Piggy file does not get closed for the entire time you're running descent. It's loaded into memory and it's there, right? So, the other files can access it. I don't know how they would access it necessarily. Maybe I do. That doesn't look local. So this is just a global variable declared in the middle of nowhere? Is that what I'm looking at? Ouch. So yeah, everybody that includes Piggy.c of all things rather than Piggy.h can use a Piggy file. Or use the Piggy file because it's hard-coded as to which one to open. All right, so create bitmap. GRS bitmap new bitmap, malloc size of the bitmap, x and y 0, width and height, parameters, type 0, flag 0, row size equals w, selector equals 0, new BM data is unsigned char malloc width times height. Okay, sure. So unsigned char, that's 1 bit, right? Or sorry, 1 byte, rather. Unsigned char size is 1 byte, according to Google. So we have 1 byte per pixel. That's 8 bits per pixel. Ouch. It's doable, but oof. Okay, we have a way to initialize the bitmap, as we saw before. So we're passing data to this. I just am so confused where it's getting the data. Let's see if anybody else uses Piggy. Nope. So the data's got to be in here somewhere. So we have a bitmap, but at this point the bitmap's already created and good. Right? Yeah. Piggy find bitmap name hash table search bm index equals I. Oh, okay. So we're returning an empty bitmap index. Maybe it's somewhere in bm read all. Right, textures, index, info, sounds, vclips. Whoops. No, these are indices. Effects, wall animations. Robot joints, weapon types, power-ups, polygonal models, gauges, dying model numbers, dead model numbers, object bitmaps. Once again, we've got these object bitmaps and bitmap pointers, but they're the size of the indices and pointers. They're not the size of the actual bitmaps. And I do not understand what's going on. How does this even exist here? Okay, it's declared at the top of the file. It's declared as null. We're setting this to bitmap bits, but this is an empty malloc. But bitmap bits is empty, right? Malloc should just allocate empty memory, right? Allocate size bytes of uninitialized storage. If allocation received, return a pointer that is suitably aligned for any object type with fundamental alignment. Whoops. So we also reference this in this function, but I don't know where we call this function. We call it we call it if we're using paging. Okay. Now this sounds insane because I don't even know how this would be possible. But it almost looks to me, because they don't initialize malloc here. They don't initialize the bits in here. They just say bitmap bits equals this uninitialized set, and then cache data equals the bits. So it looks to me that they somehow know where in memory they're allocating bits. This looks like some sort of memory call. I don't know how on earth you do that, though. Also, why is it below this? Shouldn't this happen first? Or shouldn't this happen above that? Right? Because we got our cache size here, but our cache size hasn't been initialized yet here. Yeah, it can't have been initialized. So I'm lost. Time to get out my soccer ball here. explain why bitmap bits is not initialized after malloc. Instead, the provided ecosystem handles and registers their metadata, but the actual is managed elsewhere, likely through functions that handle paging or on-demand loading. I agree. Wait, where do I see if using paging? Oh, I see it in... So there's a Pidgey page in bitmap page in function, but there's no... It's not called anywhere. How can you... how can you use a function that's never called? It's not... Wait. Wait, what? What? What is this supposed to do? Define Pidgey page in BMP, but there's no... But it's not pointing at anything. What is that? What does that even mean? What is that? What? What? Clearly don't know preprocessor functions at all. I know if define, but that's about it apparently. Okay, but then why? Okay. But then how do we load them? Right? I'm assuming that I don't recall turning on paging when I built this, so I'm assuming that this is by default not defined. Don't use paging from pig file by default. Okay, sure. If Pidgey use paging init you got no else's here. I don't understand where we are getting these, how we are loading this stuff from disk to memory if this is not defined. All of this stuff. What just happened? Did you just make that up? The header file suggests that there's a... Oh, hello. Why isn't it defined? I'm so confused. No definition. It's called twice, apparently. But there's no implementation. Um... Nope. I'm just not finding this anywhere. Okay. Um, mm, um, not seeing my CCP file. There you are. No. Thank you. Wow. Okay. Interesting. He just throws that away. Wait. What? Oh, yeah, for gauges. In object bitmaps and cockpit bitmaps. VM read all. What was I looking at? Properties read something. Oh, okay. So this is all in. What? This is all descent 2. Wow. Okay. What's our read command for this? Man, there's an ugly way to do this. no reading in bitmap. Let's see. Well, damn it. Hmm. Come on. Oh, I'm in game data. I want to be in... Okay. What? No. Copy. Not sure what I want to do here. Basically, I want to convert these textures to Unreal textures. And on the one hand, loading them all in is not an issue, not for Descent. Talking a couple megabytes. On the other hand, I don't want to create a situation where someone can crash the program by setting up a mod with a pig file that's more than 8 or 16 gigabytes, or however, right, more than a certain, a very large pig file, and loading all of it into memory at once. So I suppose there is some safety nets here. Let's take a look. Okay. New bitmap. Wait. We won't return a bitmap? What do we do? New bitmap. Integer I. Origin I. Original I? Original I. And temp I equals the bitmap index that we've just put in. Cert I is greater than 0. Less than max bitmap files, less than the number of bitmap files, and that piggy cache size is greater than 0. Okay, sure. If I is less than 1, return. So if I equals 0, we return? What's all this? This looks super redundant. Yeah, I is greater than or equal to 0. That's actually interesting. We cannot have a 0 index bitmap. Game bitmap offset I, if the offset has not been loaded correctly. What? If piggy low memory, the X lateral is we're only loading half the bitmap. I think we can ignore that one. Bitmap is equal to game bitmaps I. Bitmap flags, and bitmap paged out, stop time. Descent critical error 0. CF seek, the piggy file, game bitmap offsets, seek set. Oh, something's been confusing me with the disk stuff. The disk stuff haven't made much sense. I've been skipping over it because I didn't think it was super relevant. They mean a CD-ROM. It's very different. Okay, so what? What is this? Error is 0. CF seek, don't change error. If descent critical error, call our critical error function and go to redo it. This looks like a really weird infinite loop. Unless this exits out. disk error. If I equals 1, exit. Otherwise, retry. Okay, yeah. This is an infinite loop with an exit in it. An optional UI exit is what that is. Okay. BM data equals what was this flag? A run length encoded bitmap. I don't know what that means. What is a run length encoding? Length encoding is a compression technique with a brute force simplicity. DS displays consecutive occurrences against a signal with only one copy of the signal plus a count of how many times that symbol occurs. Hence the name run length. Okay, so it's compression. So if this is compressed, then we load it this way. Otherwise, if what? What? Okay, that's not the right way to do that. So we're reading an int from Piggy file. Oh my word, this is a mess. The things people do for compression. Basically, if this should never happen. And if it does happen, it dumps the memory. We've got a couple reads here, but no reads here? Oh, there's my read. I just missed it. Okay. Okay. So I need to read in the headers. And then I need to um then I need to use the offset in the headers to okay. Gotcha. So there's two headers going on here. There's the bitmap index and game bitmaps. I don't know why they're separated. I don't think I would separate them. Well, I suppose they're not separated because this is not an array. This is just a bitmap index. That's not an int for some reason, or not a short, or an unsigned int. Or, anyway, don't know why that's not a standard thingamajig. But that one actually kind of makes sense. Like, we use custom iterators all the time. Why not custom indices systems? But sure. Okay, so we have a bitmap, and then we make sure that our bitmap index is valid, or we do some initialization. We make sure that the bitmap index is valid. And then we load our bitmap header. Okay. Yeah, we load our bitmap header. And then we load then we have a check if we're unloading things from memory. Okay, here's the thought. What we can do is load in all of the headers somewhere, all the bitmap headers. And then do a for loop and load in one bitmap at a time in a for loop. Or 8 bitmaps at a time or whatever. Like, we can load in more, but I think one will be fine. And what that will do is make it so that you have to create a headers of larger than 8 gigabytes to crash the program, which is just not viable. It is viable, but we can add some checks there and just throw errors. It's perfectly fine to just say, nope, that this is not valid. And then we can load textures as large as we want. If some crazy person wants to put 4K textures all over Descent, we can do that. And what we're doing when we're loading the texture is we're not storing it in memory. We're saving it to a texture, a UE4 texture. Well, that's a problem. So I was thinking that we don't want to save these to disk because we don't want to enable people to copy the Descent assets. Copy and distribute the Descent assets. independently of descent. Okay, so our load texture, one at a time, can be a function. And that is perfectly fine for testing, so we can load that into Unreal, or is perfectly fine to load only the textures that the level is using into memory. That should be doable. Okay. But either way, they should be loaded into textures, not the Piggy bitmap cache data. Okay? Because this is a bit confusing, but this here, this is the actual bitmap data in memory. Right, this is just a pointer to this data. Okay. So we're going to our offset. Then we're setting our pointer, we're getting our flags, and then we are loading in our bitmap in the cache. Okay. Our bitmap size is bitmap height times bitmap width, or the size of or it's defined, there's an int defining that at the beginning. So our bitmap height times bitmap width times 1. 1 byte per pixel. Wow, that's small. Wow, okay. Let's make some notes. Okay. Why is bitmap offset not in our headers? Game bitmaps offset is its own array. Why is there no offset right here in this struct? Offset. Data length depends on the bitmap flags. Once again, why is this not stored in the header? This one even has a thing to go in the header, doesn't it? Yeah, it does. Why? Oh my word. Okay. Game bitmap flags. No offset in the header. There is a flags BM flags in the header, but it's not used until after the bitmap is loaded. Because reasons. If flag is BM flag RLE, eight. Let's see here. 4, 2, 1. Size is the first 4 bits. Size is set by the sort bits int. Else size is height times width times 1. 1 bytes. That is 1 byte per pixel. Okay, so with those notes, I can probably figure something out here. At least get started. Oh. So don't know what BM's supposed to be there, but that's clearly not. I don't know where we are. Okay, where's the... Got two of those open. We can create bitmap. We can create bitmap raw. We can initialize bitmap, free bitmap, decode data, ASM. Oh boy. Remap. Oh boy. There is a PAL. Palette that defines the available colors. Uh-huh. Okay. Create palette. We have shades of red, shades of green, shades of blue, and grayscale. Huh. 255 colors. Is Descent really in 255 colors? If so, I'm very impressed. Grayscale, how are we getting this? Okay, we got our shades of red, shades of gray. But how are we getting yellow? We got yellow on the walls. We can just kill him. These are very clearly yellow and orange. So I'm missing something. Whoops. Okay, we got green, we got orange, we got blue. Do we have lots of palettes that are defined in the file? Is that what's going on? Because this is all very clearly yellow. Yellow, orange. Those could be shades of red, but they don't look like it. Oh, this is shades of gray, yeah. That does not look like shades of gray. Okay. Oh, this is test. Where? How did you get out here? VS Code does weird things sometimes. Look at this. This is Qt6. This is not Descent reference. Okay. So this is a palette input. Build color map good. Okay. Palette color map equals find closest color. Red, green, blue. RGB, yeah. Red, green, blue. So we have a palette and we have a color map and we have a frequency. And okay. What does that do? Oh, okay. Color maps and output. Color record is equal to computer colors I minus 1. Computer color I minus 1 equals computer colors I. Return. Oh, this entire thing is if we've already computed the color, return it. Square R minus GR palette 0, 1, 2, 3. If best value is 0. Add computed color at best index 0. If okay, ignore transparent. Value is less than best value. Okay. Super transparent is 254. Just normal transparent, I don't know what the difference is 255. It's possible something to do with collision. Decode the data in BMP data according to the width and height, and the color map and the frequency. And decode data is some some assembly code. I wonder why that's relevant. Data to ESI, pixels to ECX, color map to EDI, and count to EBX. XOR clears the EAX register that we have not used. Move loads the next byte from the data array into the lower 8 bits of EAX. Okay. Increments the count for this pixel value. The pixel value in AL is used in index into the count array which treat an array of 32-bit integers. Move. Use the pixel values and index in the color map array and load the corresponding pixel value into AL. Store the map data back into the data array. Use the next byte in the data array. Decrement the pencil count. Jump back to the start of the route. Why is this assembly? This decode does not need to be assembly. Okay, so we need to somehow load a color map, or sorry, load a palette. There's a palette. I don't know. What necessarily that looks like. But we need to load a palette. We need to then load the need to load a palette. We need to then load the bitmap headers, and then load a bitmap, and then transform the bitmap by the palette. Wow, that's a lot of work. Okay. I am going to take a quick break, be right back. And after I come back, we're going to get our head out of textures for a little bit and see if we can't fix the concavity issue that we were having yesterday. See you soon. All right. So, yesterday, I was stuck on a specific section of importing a descent level. I've got descent level import almost working. Almost working. Sorry, descent level geometry import almost working. But it's not quite there yet. Let me close the door so we don't get the fan sound. Sorry. So it's descent level import that's almost working. The only thing that isn't working is certain pieces of geometry have the triangles flipped the wrong way. So the triangles need to all be, I believe, all be concave all be concave, never convex. I think. The triangles for each side should never be convex, I think is what's going on. Shoot. Unreal's going to yell at me here. Guess we're going to find out how late I can save that file. All right. To show what I mean, I'm going to start by loading into descent here. Okay, so if we head over here, oh, let's kill this thing. So you'll notice that this triangle here goes from top left to bottom right, and this quad, the long triangle, goes from top left to bottom right, and then this quad is once again hard to see because it's all like flat shaded, but this quad here goes from bottom left to top right, right, and that makes it concave. It's squished in. Same over here. We've got two quads. This one is going from the top left to the bottom right, and this one is going from the bottom left to the top right, so that it's squished in. Okay, if we go in this hallway, whoops, we have faces that are too flat to tell. Maybe even non-triangulated. Okay. How can you have a non-triangulated face that isn't flat? Unreal just came up over the top of our descent here, so let me minimize this. There we go. Because I know for a fact that these couple of places are not flat. Okay, I think I can see the triangle. I think it's here to here in descent. Yeah. It's difficult to see, but it is there. Maybe same with that one, but that's even more difficult to see. All right. So we're going to pause this and head to Unreal. Okay, and we can see that in Unreal, this triangle and this triangle are flipped the wrong way. This triangle is also flipped the wrong way. Yeah, and this triangle is also flipped the wrong way. Let's go ahead and fly through this level here and see if we can find any other triangles. Right, these are all very flat faces, so nothing here, nothing here. Wow. Nothing here. What about down here? We got any triangles? We got a couple, but nothing we'll be able to see in descent. Oh. I bet those aren't visible in descent. It's down here. Ooh, here's a couple triangles. No, those aren't triangles. Those are just lighting errors. Okay, there's a couple triangles down here, though. There's a whole group of them down here. Okay, I know where that is. Okay. And those triangles are even harder to see on this surface, aren't they? That one's... Okay, this one I can see. Stop that. Okay, so this one I can see really well. And that one's top left to bottom right. What does it look like in Unreal? That one is facing the right way. Can I see the one directly in front of me? Did I just shoot myself with a flare? I didn't even know I could do that. Yeah, this one is bottom right to top left. And then this one is... Did I just say bottom right to top left? Is that correct? Bottom left to top right. Same with this one over here. It's very hard to see on that texture, though. So yeah, those two are incorrect here. They should be facing the other way. Okay, close. So, yesterday, I was of the belief that all of my dot products when calculating the dot products when calculating the triangle concavity, as you were returning 0, like true 0, and so indicating that they're 90 degrees apart. But that's not the case. I went ahead and set up my dot products to only, or I set up my log to only if the dot product does not equal 0. And I've been playing around with these numbers, didn't get anything different. So dot does not equal 0. Then if I import, well, dot in that setup, wow. I get a bunch of logs. which means we got all sorts of dots do not equal 0. And this logging is not accurate enough. Grr. Okay. So so for some testing, we can do stuff like, let's go ahead and set all this to what I think it should be set to. Right. And we're going to compile and run it like this, assuming that it's going to be wrong. Right. Okay. Actually, before we do that, I stumbled across the right answer too many times not to check and make sure. Okay, not the right answer. I also want to go ahead and only log when I'm actually doing the flip. And that way I'll know how many I'm actually flipping. Right, if any. I think I am flipping a couple. Which, if I am, is very weird. But only log if we're flipping, and that way we'll know. So go ahead and rebuild that. Okay. While that's rebuilding, we can just mess around, right? Actually, while it's rebuilding, we can head into the options and get my joystick set up so I don't have to be fighting this the whole time. Pitch up, down, turn left, right. Slide left, slide right, slide up, slide down. Recognize the joystick immediately. This is descent to, descent D2X rebirth, or DXX rebirth, DXX rebirth, which is kind of like a rebuild of descent in C++ or something like that, make it more portable. Oh, that's right. Descent 1 now doesn't have an afterburner. How very weird. Okay. Uh-oh. There it is. Okay. So now, theoretically, you know, if Unreal doesn't take over here. Yeah. Now I've got joystick. Unreal is still taking over. Okay. All right, Unreal, we can work with you now. No need to be so aggressive. Okay. So we are theoretically flipping a lot of triangles. That's really interesting. But I'm not seeing any of those triangles flipped. So maybe we're flipping the wrong triangles, or maybe the the floating point error is too high or something like that. Because something to remember is we're using floats here. Descent used fixed point floating numbers, so that might change how the error is handled. Let's go ahead and rebuild. Been a long time since I played Descent. Okay. All right. Okay, yeah, I just don't think it's touching those. I think these are not registering on the numbers. That one's the right way though. Don't know where else in the level. Well, I guess there's over here. That one looks like it's the wrong. Where is that? Where am I looking at? Because those look like some moderately. Not seeing any difference. That's kind of the weird part, is I'm not seeing any difference. Like. Maybe instead of logging the dot product here, because clearly we're doing something, I should be logging the... I should be logging the index? How do you even get the index? VI? Whoops, where'd it go? I'm guessing. Wait a minute. No, it's fine. Is it fine? Zero, 1, 2, 0, 2, 3. Our long edge is going to be 0, 2. Long edge is going to be 0, 2. 3, 1, or sorry, 2, 1, 0. 3, 2, 0. Our long edge is still 0, 2. It's going in the opposite direction. Okay. 0, 1, 3. One, 2, 3. Long edge is going to be 1, 3, starting from the back top and going to the round. 3, 1, 0. 3, 2, 1. Long edge starts here and goes to here. Okay, on this one, long edge is here and here. So this is like positions 2, 2 and LE3, right? Because this is the third position of our long edge. And this is like LE3 and LE2. And this is like LE1 and LE3, 3. And then this is like LE1 and LE2. Okay, that's interesting to me. At the very least. Shouldn't, if we're going backwards. Okay. What if we match the long edge positions? switch this back to greater than, please. What if we match our long edge positions? Okay, so so we want the long edge position to be in 2, or sorry, in 3. It is in 3. 0, 2 is 3. Right? 3 and, but this is position 1. Derp. So what if we want our long edge to be in position 1 here? Right, we would have to rotate these backwards one, so it would be 2, 0, 3. This doesn't make sense. Long edge is in position 2 and position 3, yes. Long edge is in position 1 and position 3, yes. So if we want this long edge to be in position in position 2 here, we want to do 0, 3, 1. Don't think that's going to work, but worth a shot. Okay. Oh, whoops. Did this wrong. This goes backspace. This goes here. And did this wrong. Unspecified format specifier. UE5 text format specifiers. Fires. That's super not helpful, guys. List. Nope. I just want to display an integer. Why is there no documentation for this? Why is there no searchable documentation for this? For reference to everybody, if your documentation is not searchable by Google, it is not searchable. I don't want to have to deal with whatever stupid search you come up with on your own. Because they're always bad. And I don't necessarily know where they are. Right? Like, this doesn't tell me anything. It just tells me, this is where you learn about string handling. Okay. Does it tell me anything about format specifiers? I don't know. You didn't include any text related to my search. This is terrible. Specifier for an integer. When ChatGPT is better documentation for your system than your own documentation, you need to fix your documentation. Okay, it says I thought I'd used I and I hadn't worked in the past. Let's try it though. That works. Okay. Did I not give you 4 variables? Oh, oops, I did $i instead of %i. Derp. Gonna need to fix that. No change that I can detect. We do have our vertex indices that we flipped. There seems to be a lot of them. They all seem to be very small, which is odd. I do like keeping the long edges the same, just in case. But what just happened, Unreal? Oh, you decided you want to be on top because you're auto-saving. Brilliant. So I'm wondering if this is some kind of floating point error. I don't exactly know. However, there is something that we can do to kind of test this. Or rather, I've been thinking, and I've come up with a different algorithm for how this was going to work. So, if you remember from yesterday, I built a little convex tester.py. Just a little Python file with a very simple vertex array to tell me if this formula even works. It does work, by the way, but the system here, yesterday I was having a whole bunch of problems with it because I had it listed like this instead of the right way to list it, which just made everything 90 degrees because we just put two identical triangles together, basically. Or yeah, we had two, yeah. not two identical triangles, but one of our triangles wasn't a triangle, it was a line. So it wasn't quite right. So now we want to go ahead and do a calculate normal function. Where we're going to take in vertex 0, vertex 1, and vertex 2. And the reason we're going to create this calculate normal function is that we're going to calculate the normal of both faces and then compare them to figure out if they're acute or obtuse, right? Because if they're facing one another, then we should have an acute angle. But if they're away from each other, we should have an obtuse angle. So, no need to be printing all this stuff out. And normal. Okay. Vertex 2 minus, whoa. What is up with this? This is not a correct normal calculation. I don't think. Yeah, vertex 1 minus vertex 0. Vertex 1 minus vertex 0. Whoops. And we cross edge 1 and 1, 2, then we normalize, and then we return. Great. So, instead of doing all this, we can just normal 1 equals calculate normal, and then we can just do vertex 0, vertex 1, vertex 2. Okay. Let's see here. Oh, no, it's all the way out here. Got it. All right, so if we run this, dot slash convex test dot, oh. We get a nice little calculation here. That is telling us that this is a positive dot product. Okay. Now, what I'm thinking that we do is instead of this, using the edge long here, actually, I'm interested. Before we get rid of this, I'm interested in just doing a little bit of math here and kind of figuring out what this does. Okay, that switches it to a negative dot product. Interesting. Very interesting. Okay. And then if I rotate these around, back to a positive dot product. Which means, based off of that math, it should be like this. Because these are rotated, this also has to be rotated. Anyway, we'll give that a try. But, no, that was a fast reload. Yeah, didn't do anything, unfortunately. All right, but what I am thinking is what we actually want to do here is calculate normals for both of the faces. Ooh, yes. So vertex 3, vertex 2, vertex 0. Then we can go ahead and get rid of this print. We can go ahead and get rid of this print. And then we can do a dot of normal 1 and normal 2. I don't know if dot works all the way out to 180 degrees. We're about to find out. Because, yeah. It might switch from 1 to -1, or from -1 to 1? Don't know. Normal, let's see here. Go ahead and print normal 1. And go ahead and print normal 2. And then print the dot product. And we'll run that. It's very funky looking. So this gives us -3. And if we swap these guys around, I'm hoping that we get positive. Whoop. And we don't. That's unfortunate. What if we swap just one of them around? Now we get a positive. Okay. So Wah! Lost it. Okay, there we go. Not product visualization. There we go. So, as we head to 90, dot product is going to go to 0. And as we head towards 180, it's going to go to 1. Oh, okay. So do you see that? I can't tell. Dot product between (180) and there is no such thing as a dot product of 270. Right? And this is 90 again. Shoot. So there's no way to tell between this angle and this angle. Okay, but how do we use that? Because the dot product between a vector and its cross is always going to be 0, just all the time. Let's head back to VS Code here. And what are we looking at? Do we have an np.cross? Okay. Okay, cross is a vector. And it's not in a standardized direction, obviously. So how do we use it? Right? We don't know. Okay, but the cross product does give me a vector I can rotate around. It gives me an axis of rotation. Um, okay, we need a normalized cross. And then... Wait, what? Or a vector, but lie within a plane with a special known vector n. What? Is not the plane the cross product every time? Does not come with a fixed orientation, which means you cannot clearly determine the angle of rotation either. Be always positive and orient the axis so it fits positive angle. But isn't not the cross product the angle of rotation? I'm really concerned about the minus there. That's not... I don't have a 3x3 matrix. Do I have a 3x2? Or maybe I do have a 3x3 matrix? As in, I have the normal? And this is turning out to be much harder than I was expecting. Vectors in the plane of their cross product.
Shoot. I'm starting to understand, well, I'm very much understanding why Descent did it the way they did it. And I'm very much not understanding why it's not working. That's the real weird thing, is why on earth is the code that I'm using here not identifying the appropriate vertices? What? The only thing I can think of right now is somehow we're not constructing the right triangle. Zero 1 2 0 1 2. ABC. ABC. Oh, why are we calculating triangle normal here? We don't need to do that. Yes, we do. Do we? Okay. Nothing wrong down here. We appear to be getting different vertices for all of our thingamajiggers. We appear to be getting negative dot products. I do not understand why this isn't working. You tried dot products greater than 0. You tried dot products less than 0. This is if else. This is not problematic. Let's make some holes in our mesh, shall we? Let's figure out what triangles we are apparently replacing. What? I thought I fixed that. I did fix that. Did I just not clear the log? Yeah, I just didn't clear the log. Oh. Oh. Hello, hello, hello. Do you see this? That's the same index. What? Where am I building those indexes? 4 equals sides to verts I. Wow, of all the bugs. I hate that. Probably spent 4 hours on this. What just happened? No, we just got slow. Okay. Of all the bugs, okay. These are the right direction. Those are the right direction. Yay! Okay. It might be worth it to get an AI set up only to find those kind of bugs. Right? If I can limit an AI to only finding those kind of bugs, I will be so happy. Just stupid stuff like that. Okay. That is now working correctly. And just in time, because it is time for me to head off. I will see y'all tomorrow. Thank you for coming.